Okay, so now we're taking a deeper look at more means and variances. Okay, so we learned earlier this year that when you add a number to everything in the data set or subtract it, the mean increases or decreases by that amount. The variance, standard deviation, or any measures of center change the same. So pretty much we're starting off with those two rules. You can see the expected value. If I add that to the stuff in the data set, that's how much the expected value changes by. If I add or subtract everything in the data set, the variance stays the same. So I have a situation, okay, so we've determined that the couples dining at the Quiet Nook can expect Lucky Lovers discounts averaging $5.83. The standard deviation for that was $8.62. Suppose that for several weeks, the restaurant has also been distributing coupons worth $5 off any one meal, okay? So that's a discount per table. So if every couple dining there on Valentine's Day brings a coupon, what will the mean in the standard deviation be? Okay, so right here it's $5 off, so really what you have there is minus 5. So my new mean is going to be even less than what it was. Now, you have to think of it this way. The discount was $5.83, so really that was already a negative $5.83. Okay, an average discount. So if you take that 5 away from that, my new expected value or my new discount is going to be negative $10.83. Now my variance or my standard deviation, both are going to stay the same because you were adding and subtracting. So that's going to stay at 862. And again, that one was a little different. You got to be careful with that because the discount was the amount off. So my new discount would be negative 1083, even though I didn't quite put it that way. Or you could just say a discount of 1083. You just have to put that in some way. What you need to make sure you don't do is take the 583 minus 5 and say the discount changed to 83 cents. Because with that coupon, that's not quite what happened there. Now, going back to what we did before, when I multiplied the data set by a number, the mean also changed by that amount. Okay? Now, your variance is going to change too, but this one's a little bit different. Now, notice they gave you a formula for your variance, not your standard deviation. Okay? So, this is variance. So, if you have standard deviation, you have to change standard deviation to variance to use this. So, you're going to square the standard deviation. Okay, and then you square the multiplying factor. So just kind of remember that your standard deviation, that's your variance, and that's your standard deviation. So you're really just going to square your standard deviation. Okay, so now let's put this into application. Okay, so on Valentine's Day, we're back to the Quiet Nook. The couples may get a Lucky Lovers discount for $5.83 with a standard deviation of 862. When two couples dine together on a single check, the restaurant doubles the discount offer to negative 40 for an ace of hearts on the first card and negative 20 on the second. They want to know what the new mean and standard deviation would be. Okay, so what they're saying here is double. So in essence, they multiplied everything by 2. So that's what's occurring in this case. So let's start with our mean. Our average discount was $5.83. Since everything was doubled, this wasn't bad. Our new discount is going to be that $5.83 times 2. So you'll take $5.83 times 2, and you'll have our new average discount. So $5.83 times 2, new average discount is going to be $11.66. So this is kind of like what we were doing back in Unit 4. Now, what makes my standard deviation a little bit different is, first of all, the multiplying factor is squared. So if you go back to that formula, it's right here, I'm going to square what I'm multiplying by and then multiply by the variance. So the first thing I need to do is figure out what my variance is. So if my standard deviation is 8.62, my variance is going to be 8.62 squared. Okay, so that's going to be 7430. So let's get our new variance and then our new standard deviation. So our new variance, okay, so our new variance, we'll just put that there, is going to be 2 squared, because it was a multiplying factor squared, times the 7430. So I'm multiplying that by 4. And you're going to get 297.2. Now, the problem is, did they want the new variance or did they want the new standard deviation? They wanted the new standard deviation, so unfortunately I didn't give quite enough room here. So to get my new standard deviation, I need to take the square root of the 297.2. So I'm going to take the square root of that. And so my new standard deviation is 17.24.